All right, this is part 2 of our introduction to polygons. So if you haven't watched the part 1 video, go back and watch that now. Okay, part 2. Now, there's also ways that we classify polygons, and that is whether or not a polygon is convex or concave. Okay? A polygon is convex if there's no line that contains a side of the polygon. If no line that contains a side of the polygon contains a point in the interior of the polygon. And a polygon that is not convex is called concave. It caves in. Now, these are very confusing descriptions. They don't really make sense. So I think it's just better to just jump right in and talk about what these mean with some specific examples. Okay. So what we have to determine is if any of these are concave or convex. Remember, concave is if the polygon caves in. Okay. And here's what this first part of this means. What it means is if I draw a side of a polygon as if it's part of a line. So here's a side. If I draw this side as part of a line, so it's a line that extends all the way out in both directions like that, okay? If I were to do that for every side of this polygon, if any of these lines went inside of the shape, that would be a concave polygon. If all of these lines that I'm drawing do not go inside of this shape, the original shape, then that is convex. So when it's talking about a line that contains a side, what it's basically saying is imagine that every side of the polygon is part of a line. If that line goes inside of the shape, then it's concave. If none of these lines go inside the shape, then it is convex. So you can see, because all of these lines that we're drawing, if we draw each side as if it's part of a line, if none of those lines go inside of the shape, then it is a convex polygon. Now, that probably wasn't very clear to a lot of you, and so you'll see what I mean with this next example. Let's take this side right here. If I draw that side as a part of a line, you can very well see that this line goes straight through the middle of the shape. It goes straight through the shape for this section right here. Because this is a polygon, we did it on this slide up here, right? We already said, yes, this is a polygon right here. So it is a polygon, but the sides of the polygon are in lines, are part of lines that would go through the shape. So this is an example of a concave polygon, because as you can see, you can just kind of see and look at the shape and see that the shape caves in. There are these parts like here that kind of poke into the shape, and because they do, we know the lines containing them are going to go through the shape like that. Okay? Go ahead, pause the video, and I want you to try to do these two on your own and try and say whether those shapes are concave or convex. All right, so you should have decided whether or not these shapes are concave or convex. And so for this one, we can draw each side as a part of a line and see if any of those lines go through the shape. That one does not. None of those go through the shape. That one does not. That one does not. And that one does not. Because none of those lines that contain the sides of the shape goes through the shape, then we know that this is a convex polygon. And right here, if I draw the line that this side is a part of right here, you can see that that line very clearly goes straight through the shape, so it is a polygon. And this polygon is concave because it caves in. All right, so there are some examples. We classify polygons just like we do triangles in the following ways. A polygon is known as equilateral if all of its sides are congruent. It is known as equiangular if all of its angles are congruent. And if both of those things are true, if it's equilateral and it's equiangular, then it is known as regular. Pretty straightforward. So equilateral, all the sides are congruent. Equiangular, all the angles are congruent. And regular, if all the sides and all the angles are congruent. So we have some examples down here. What I want you to do is I want you to go ahead, pause the video, and determine if these shapes are equilateral, if they're equiangular, or if they are regular. All right, so hopefully you've gone through and determined which of these are equiangular, equilateral and regular, and so we're going to do that now. This shape shows us, the tick marks show us that all of the sides are congruent. It doesn't say anything about the angles, so we can't assume anything is true about the angles. And so because all of the sides are congruent, we would call this equilateral. All right. Here, there are 1, 2, 3, 4, 5, 6 sides, so this is a hexagon. And it tells us all of those sides are congruent, so we know it's equilateral. And it also tells us, because of these arc marks, that each of the angles are congruent, so it's also equiangular. So because it's equilateral and equiangular, this is a regular hexagon. And here, it looks like the sides might be congruent, but it doesn't give us the tick marks, so we cannot assume that. But it does tell us that all of the angles are right angles, and we know that all right angles are congruent. So we know that this quadrilateral, this is a quadrilateral, a four-sided polygon. This quadrilateral is, in fact, equiangular. All right. Very good. And then our last slide of the day is one final rule. That's theorem 6.1. We learned a rule about triangles, and that was the angle sum theorem, triangle sum theorem, which said that the measure of each angle of a triangle has to be 180. Quadrilaterals have a very similar rule, except this time the sum of the measures of the interior angles of a quadrilateral have to be 360 degrees. Okay, so all of the angles should add up together to be 360. So if we're given these angles here as x, x minus 20, 80, and x, then all of those angles must all add up to be 360. I want you to go ahead and set up an equation that would allow you to solve for x, and go ahead and do that now. And when you're done, you can come show me that you have done this problem, and then I will give you the practice problems for this section. Thank you guys for paying attention. Thank you guys for pouring into this. The next section will be chapter 6.2, and chapter 6.2 is on parallelograms, as an introduction to parallelograms. So you can be looking forward to that video, but go ahead, show me this problem, and you can get started on your practice problems.